All right, so welcome to Drupal 8 Disassembly. I'm Dave, I'm the CEO of Coldfront Labs, and I'm Spot Zero on Drupal.org. I've been tinkering with Drupal for a long time, since the early Drupal 6 days, and generally have been a back-end Drupal developer, so I have been pulling apart Drupal from the bottom for a long time now. So, Drupal 8, why are we disassembling it? Drupal 8 represents a lot of challenges for developers coming to Drupal 8. And that's because understanding Drupal 8 core by itself can be pretty difficult. It's got some daunting features. Hey. It is very different than the previous versions of Drupal. There is a lot of complete mindset shifts or switches than any of the other versions of Drupal have had, especially like going from one to another. So this makes Drupal 8 very challenging to go to for previous Drupal developers, because if you're used to writing Drupal code, now everything is different, and you have to relearn a lot of stuff. Let's say you're just a PHP developer. Well, Drupal, an application that you use that doesn't actually get you the application that you want, is huge. And the argument is, why would I use this when I could just write it, and then I would know all the parts of it? And so there's a challenge there if you're just a PHP developer. There's a lot of new stuff, a lot of new concepts. Let's say you've got let's say you're a Symfony developer. So you have a lot of really good knowledge already about the structure of Drupal 8. Well, Drupal 8 retains a lot of Drupalisms that Drupalers would be familiar with, but are going to be challenging for a Symfony developer who is never going to sort of seen these kinds of structures before. So, what we're going to do is we're going to dissect and analyze Drupal 8 as if it were a completely new application to us. So we'll pretend that we don't know anything about previous versions of Drupal, or about applications, or Symfony, and we'll start taking apart, looking at the execution flow of this thing, and try and analyze like how this thing starts, and how does it go from, so I'm going to a URL, to a page being generated. So note about questions and comments. We're going to be sort of moving through the Drupal bootstrap, as Drupal bootstraps. So if you have any questions or comments or anything, just wave, and we'll talk about things, because there's sort of a lot of stuff in here, and it's better to talk about these sort of things while they're relevant, for when we move on, and you'll be like, oh, I had a question about this thing that we barely remember. So yeah, just flag me down, and we'll talk about it. All right. So first impressions. Let's take a look at Drupal. So when you install Drupal 8, you get, let's make that bigger. Let's make it bigger with the right key. There we go. So when you install Drupal 8, you go into the directory, you see a bunch of files. And so what do we see here? Some critical things that we see when we're looking at this application. If we start in alphabetical order, we see autoload.php, which is some code. We see, and it's cut off because of overscan. So we will resize this so that you guys can see past the overscan. Let's try that again. There we are. You see composer.json file. That means something. Composer.lock, sort of also important. If we look for hidden files, there we are. We see an htaccess file, which is web server instructions. We also have a web.config, which is more web server instructions, but for a different web server. And we see a bunch of other files as well, the most important being index.php. So what can we infer? Oops. Well, we found the composer.json, composer.lock, so we know that this has PHP library dependencies. Otherwise, why would you be using the file for controlling PHP dependencies? We see htaccess and web.conf. So those are, we know that this application needs to change the web server to work. We have index.php, which is a common starting point for PHP applications. So we know we are dealing with a PHP application. And we see autoload.php, which we happen to know is Composer's autoloader. So it makes sense with composer.json and composer.lock. It's using the Composer autoloader. So we'll talk about Composer, because I say Composer a lot. And if you're coming from Drupal 8, you may never have ever used Composer. So what is Composer? Composer is PHP's dependency manager. Before PHP's libraries, if you want to use sort of shared PHP libraries, we used to have Peckle and Pear. And this was great because it also managed extra PHP extensions, which let us run C code in PHP. And it sort of got hacked to also work as a dependency manager for PHP libraries. But as the ecosystem grew, we started getting lots and lots, the general PHP development community, not Drupal, because Drupal didn't really use a lot of external PHP libraries, started having this problem of how do you manage these dependencies. In the Drupal 7 world, we had sort of the libraries module and the libraries directory, and we just unzipped or untired any of our PHP libraries we downloaded into that directory. But the rest of the PHP community started using this tool called Composer. Composer is backed by a site called Packagist, and everyone can register a new PHP library on Packages, and then you can use Composer to download it. The composer.json file for a PHP project defines all the libraries and dependencies that this particular project has. The composer.lock file records a snapshot of the dependencies there. So it records which versions of each library were installed. And this lets us do repeatable builds using Composer. So the first time we install an application, it will download all the latest versions or whatever it says in the composer.json file. But and then we'll generate a lock file. But if we have a lock file from Drupal, Drupal is telling us, or telling Composer, these are the versions of all the libraries that I want to run Drupal. Something else to know about Composer is we have a vendors directory, and that is where Composer sticks all of its PHP dependencies. They go in vendor, and then there's a namespace directory, so it's who's ever providing, and then another of whatever the library was called. So Composer dependencies our namespace, will be name of author / name of project. All right, web server integration. So we know Drupal 8, like previous versions of Drupal, needs to change the behavior of the web server. htaccess is web server configuration that's read by Apache, and web.config is web server configuration that's read by Microsoft IIS. If we crack these open and take a look, the really important takeaway from what Drupal is telling the web server is if the request matches a file in this directory, serve the file. If it does not, just execute index.php. So what we've gathered from this is no matter what happens in this application, execution of the application always starts at index.php. There is not a sub-application or sub-applications that run. It's not like other PHP applications where you have a directory and every page is a different .php file. We know everything goes to index.php. Or at least that's what it's trying to do. All right, so done with our first impressions. Let's take out the scalpel or wrench, depending on what we're using, and dig in and take a look at what's happening. So this is actually the entire contents of the index.php file for Drupal. And it's pretty short, so sweet. This should be easy, right? So let's start analyzing what this PHP application does. First thing it does is it sets autoloader to be equal to require once autoload.php. Cool. So we're already leaving the index.php file, but that's expected. So let's look at autoload.php. Well, this file is kind of a strange file. It only has one line in it. Well, 2 lines if you count the starting PHP tags that PHP executes. Anyways, one line that executes, which is the following. And it says return require dir, which is the directory of, which is PHP superglobal, which is the directory this file is in, and then /vendor/autoload. So already the first line of Drupal executes code that isn't Drupal. It goes into the vendor directory that we know is for third-party libraries. So the first thing Drupal does is execute an external library. Well, it turns out there's a good reason for this, and that is auto-loading. So something the Drupal community kind of missed was that in Drupal 7, we were just ahead of the curve, it got added in after, was class autoloading. PHP supports class autoloading, sort of. So it doesn't do it by default, but instead what they do is they give you a callback that lets you actually talk to the PHP engine. And the callback is SPL autoload register. And you give it a function, and what you're telling PHP is every time you find a class, a reference to a class, and that class happens to be undefined, before you throw an error, call this function. And so the goal of this is that that function will take in the class that PHP is looking for and then define it by loading some file. And then that will provide auto-loading. Now we can do things like refer to classes without knowing where they are, or without that file being included. So PHP files get included into the application execution as they're used. And you don't have to do the Drupal 7 thing, which is just find out all the modules that are enabled and then include all the code so that we have it all in our global reservoir. We can just include the files that we want to use. So this is in the vendors directory, so it's not ours. Or not Drupal's. I shouldn't say ours. So what is this? This is Composer's autoload. So Composer's autoloader is a de facto standard for autoloading. So we don't need to worry about implementing any autoloading libraries, which is nice. Composers does that for us, and it implements a standard for PHP autoloading called PSR4. And this standard is authored by PHP Fig, which is a PHP standards group. Let's take a look at this. So who are these people that write these PHP standards? Well, they have a bunch of them. PSR4 is their standard for autoloading. Here goes in terms of how autoloading should be done by namespace. You give it some search directories that will have code in them, and then the directories are going to be the namespace of the class, and then the class name.php is the file. And then here are the various PHP PSRs, so standards for doing certain things that they've put out. So basic coding standard, coding style guide, logging interface, auto-loading, sort of caching and things. So that give these people some credibility. If we sort of look at some of the names, we'll see if we recognize some of them, like Larry Garfield, who appears a lot. And then, where is it? Michael Hess. So Michael Hess is one of the leads on the Drupal security team, and Larry Garfield does lots and lots of Drupal stuff. It'd be hard to pin him down on one particular thing. So it is sort of the PHP Fig group is the G, but the PHP Fig is a standards group that includes Drupal developers. So it's a pretty good standard, or a pretty good group that represents a lot of the major PHP frameworks. So it's a fairly agreed upon standard. All right. So that's where the auto-loading goes. We now know that whenever we see references to classes, then that means those classes get auto-loaded depending on depending on the namespace of the class. So if we go back to our index.php, what is the next thing that happens? Well, we use some classes, so it's just these namespaces are going to be, we're not going to refer to them by the full namespace. But the next thing that happens is we have kernel equals new Drupal kernel. That sounds like Drupal, probably not a contributed module. Then we have request, and request create from globals. We know because of the namespacing up there that this is a Symfony component HTTP Foundation request that we're creating. We then give it to the Drupal kernel, and the output of Drupal kernel is a response. And then on this response object, we call the send method, and then apparently we terminate the kernel with the request and the response. So pretty simple stuff. We can sort of deduce the way Drupal 8, what is sort of happening here in Drupal 8. So let's talk about some of the things that we're looking at. So the first is the Symfony request that things seem to be based off of, that all the input for the Drupal kernel is. So the Symfony request class is actually just a wrapper around the standard PHP superglobals that you would get when an HTTP request was made. So thing _get, post, cookie, file, server. This wraps it and manages it so that you have methods for pulling data out of there or accessing it. The nice thing about it being a wrapper class is that if we want to write unit tests for something that we're passing a request to, we can create synthetic sort of request objects, and because our application now isn't checking superglobals for data directly, it's checking in this request object. We don't have to do weird things in our CI test like set superglobals that if we're going to run more than one test for, then we have to make sure we unset all the superglobals. Anyways, we don't have to worry about any of that because we can just destroy the request object, make a new request object, fill it with synthetic data, and toss a new test at it. So, kind of a useful wrapper class. The other really important class that we see there is the Symfony Response. And this is another wrapper class, but it wraps everything that we're sending back to the user. Back in the HTTP response. So this manages all the things that we send back as a web server, HTTP headers, HTTP response code, whether we're doing a redirect, whether we want to set cache headers, so that if we want to manage expires or e-tags, we can set it all inside this response object. It also handles streaming of any data that we're actually outputting, so the markup. We don't print it, we give it to the request object, and the request object will do something with it, probably just print it. But it means that we could, once again, write some unit tests with this without actually needing to sort of collect the output of the application. All right, so if you're really new to this, then one big problem you probably had is what the heck is Symfony that I keep talking about, that all these classes belong to? Which is an important question because I've said Symfony a whole lot of times. So Symfony is a collection of components used for building web applications. So the goal is to write these really useful, reusable PHP components. For building PHP applications. Symfony components together make a framework for building PHP web applications. But you can use just pieces of them. I know that the one I really like in non-Drupal projects is the Symfony YAML parser, because it is super easy to use and include. So it is sort of nice to just, if I have any config, to stick in the YAML files. And the Symfony YAML parser means I don't have to worry about figuring out a parser for it. And like I was saying, the Symfony components are full of all kinds of libraries of useful things. Okay, so the other thing I should talk about Symfony is really important to Drupal 8 because Drupal 8 is essentially a Symfony application. It uses the full Symfony framework stack to operate. And it is built on Symfony 3. So at one point, Symfony 3 is the old version of Symfony. The new version of Symfony is Symfony 4. And moving to Symfony 4 is going to break a lot of APIs. So in the future, Drupal, when Symfony 3 becomes unsupported, there's a good chance Drupal 9 is going to be the Drupal 8 on Symfony 4. Yes?
How fun is that upgrade going to be?
Well, it'll break the contrib modules, but we're used to that. We have that problem with minor releases, so we're good. We're good. We're all pros. We'll be fine. So that's sort of company, and it sort of really also hits home to how core Symfony is to Drupal 8. That switching to Symfony, the next version of Symfony, is where we're going to say, all right, well, it's going to be Drupal 9 now. All right. So going back to our code, the second line is we asked for a new Drupal kernel. So we're starting this Drupal kernel. We know that it's called Drupal kernel, but we're using the namespace Drupal core Drupal kernel. And so that is the namespace of this particular object that we're creating. And so auto loading should take care of it. It's going to be somewhere that corresponds to Drupal core Drupal kernel. Oops. So it turns out that the Drupal set a whole bunch of auto-loading base directories for the composer autoloader, and its namespace for autoloading is core, where Drupal moved all of its core files at the root, and then lib, and then all the classes that got autoloaded are under that, following the namespace. So once we get to that point, if we want to figure out where the class file is, we know they're autoloaded from that directory, if it's in the Drupal namespace. So we know that since the namespace is Drupal core Drupal kernel, or the object name is that, we'll find the file in core lib, then Drupal core, and Drupal kernel.php. And that's the file that gets autoloaded. So what does Drupal kernel do itself? Well, luckily, I was trying to figure out a description and how to talk about it, because it does a lot of different things. But it turns out it actually had a really good comment at the beginning to describe what it does. So I didn't need to write anything. So I erased all the stuff I'd written and copied the comment. So the Drupal kernel class is the core of Drupal itself, which we kind of know from looking at index.php. It's the only thing that starts. So this class is responsible for building the dependency injection container, also deals with registration of service providers, and allows registered service providers to add their services to the container. Core provides the core service provider service, which, in addition to registering many of the core services that cannot be registered in core.services.yaml file, adds any compiler passes needed by the core. And then some examples of that. All right, everyone got that? We're going to need to look at the code? All right. Let's talk a little bit about, well, let's dig into what this file does and see if we can decipher any of that nonsense. All right. Well, first thing that we need to know is it uses the word service like a lot of times. So it must be an important word. So what is the service? So a service is just an API that happens to be wrapped in a class. And that is sort of an API that can now be loaded by the autoloader, which is really nice. So instead of just having global functions like we had in Drupal 7 or in other libraries, there now we instantiate a class and we call its method. So instead of Drupal send mail, we can load the email service and call it send email method. And that's what the service is. Specific functionality gets to be separated into these service classes, get to be autoloaded. And the nice thing about setting them up as services is they become really reusable. And then it's really easy to write unit tests around them because they should have everything they need. So what is a service container? Because this is something else I kept talking about a lot. So this is actually a Symfony concept that Drupal is taking. So services, of course, need to be loaded for you to use them, and instantiated so that they have everything you need. But if this is going to be in any way efficient, you want something that makes sure you only have one instance of every one of your service classes. Because pretty much everything in Drupal is going to need like the current user service that is able to tell if a user is logged in or not. And you don't want that instantiated like a bazillion times. So you want to make sure you only have one instance of each service. So the Symfony service container is, well, itself a service that manages all of the other services. And it will cache all of the services that have been instantiated. So if you ask it for a service, it will just give you a reference to the instantiated instance of the service instead of letting you needing to reinitialize it. Because we have this centralized service container, the service container can also manage dependency injection, which was another keyword that was in that comment. So dependency injection comes from other frameworks, but is used for services. And this is just a technique for making sure that we can have services. So one problem that services generally had is sometimes a service needs another service to start. If you're going to have a current user service, it'll probably need a database connection service so that it can check the user table. Because you wouldn't want every service to try and do its own database stuff. Or if it was a database logging service, yeah, it would need a database connection service as well. So these services sort of have these dependency chains. So what can we do to tell our service container about this so that I don't want to initialize all these services, give me this service, then feed it to that service, and give me that service, then feed it to that service. I don't want developers using my service to have to do that. I would like the service container to do that. So essentially dependency injection is we just say, if you write a service and it needs another service, then in your constructor for your service, explicitly put it. So that you can't initialize the service without all of its other dependency services already being initialized. And that way, the code itself enforces a dependency tree. So dependencies must be injected into a service to even start it. And it means that the service container can now deduce which services a service needs to start up. So, how is this recorded into Drupal? Sounds like we have a lot of services. So how is this defined and exposed to Drupal? Drupal, Symfony services, Symfony supports a lot of way of registering things, and Drupal uses those ways differently for different things, but for services, it uses the YAML way. In modules, you can have module name .services.yaml, and this is where you expose your services to Drupal. And service definitions look a little something like this. They're in a section called services, in case there's other data in here, and there can be. And then you have a service name. I have service 1. And then it says what class service 1 is. So somebody asks for service 1. The service container will instantiate, there's the word, app-bundle services 1. There we go. Now I know how to, if somebody asks for service 1, I know what object to give them for service 1. Let's say there's some dependency injection, and we want to, or a service has a dependency, and we want to let the service container know about dependency injection for it. So we have service 2. Service 2 actually needs service 1 to be initialized. So we have an area called arguments, and the @ says this string is actually refers to another service. And this is an argument given to this class. So if someone asks for service 2, the service container, there we go, knows that to initialize service 2, it needs service 1, so it can initialize service 1, feed it to service 2, and then give you an instance of service 2. Arguments can also be sort of static things that are defined in these files. If it just needs a string, it could also be some other data too, but we won't get too much into this file. Oh. An important file to know about in Drupal 8, if we go into core, since core is where Drupal core now lives, we happen to see an important file called core.services.yaml. Based on what we know, these must be Drupal services. The services that Drupal exposes to itself. So if we take a peek, let's see if we're confirmed. So we have a bunch of parameters here. There we are. So now we're in a services section, and we can see we have lots and lots of services. We have a cache context.cookies service, and here's the class that does it. And it takes an argument. That's another service. Request stack. That sounds reasonable. So we could look for the service request stack. Oh, that's going to be a problem. There we go. So here's the request stack service, and we see that it is the class that is initiated to provide the service is the Symfony Components HTTP Foundation request stack class. And so if somebody asks for this class, this service, pardon me, that's the class that it gets. All right. Getting back to our index.php, once we have an instance of Drupal kernel, and we sort of read the comments from Drupal kernel does, Drupal, the comments say that it starts up the service container thinger, and we know what a service container is and where it gets its definition for services now. So I think we can sort of proceed to the next line, which is Drupal kernel arrow handle. So this is the real entry point for Drupal to start. It accepts a request as a parameter and returns the response. So we know it takes the HTTP request and gives us the output. So pretty straightforward. So what does it do inside? It initializes the environment. It bootstraps Drupal so that it can actually respond, and then it passes the request to, it passes the request to an HTTP kernel. So we could go look at the code, but this is essentially what the code does at this point. Let's talk about what each of those things do. So the first thing it does is initialize settings. So this happens right away in the handle function. It initializes things. It does the common Drupal thing we know of loading the settings.php file, which is where you store any Drupal settings and your database credentials, more importantly. It validates the request. So if Drupal can figure out that the request is valid right away, it will try and do so that it can return things like 403s and 402s. Just if there's any reason to deny or say that the request is invalid, it does so really early in the starting process. And it also sets up the auto-loading cache. So the autoloader by itself will get a list of places to check for namespaces. So the first would be core lib, because that's where Drupal is. But also, as Drupal starts, it's going to add more places to that, like all of the enabled modules. One problem we're going to have eventually is when we have a lot of enabled modules, the list of places to check for the existence of a file becomes quite long. And so we don't want our autoloader to be checking, well, here's the places you got to look for files that correspond to this namespace. So it sets up a cache for that. The next thing that handle does is it runs Drupal kernel boot. And the boot method initializes the service container. So it goes through and it compiles all the services.yaml files that it can find. And it bootstraps the service container, and it starts a few core services that it needs to do its own validation. So there is a service called Drupal, which is the Drupal service, which has a bunch of a lot of the super globals or global functions we're used to in Drupal are now in the service that lets us ask things for Drupal. The current user service because Drupal's behavior depends very much on who is logged in. And this session service, which actually, those are in the wrong order. You need the session service before you need the current user service, but that's okay. All right. So once it's done that, let's go take a look at some code. How about that? That's more fun. So we're going to core lib Drupal core, and then we have the Drupal kernel.php. All right, so here is the handle method. Maybe I'll just shrink this slightly. That's just making the window smaller. All right, so the first thing is boot environment and initialize settings, which we talked about. And then if there's a problem connecting to the database, just put up the maintenance page. Else, run boot. We talked about boot. Starts up the service container. And then response equals this get HTTP kernel, and then call handle on the HTTP kernel. If we take a look at what HTTP kernel does, it actually starts a service, which is called HTTP kernel. There we are. There we are. So this container, which calls the source container, get HTTP kernel and respond to it. I thought there was more code here. That was actually not too bad to look at. So, and then we call handle on that, and we get the response. And that's pretty much what this handle function does. It loads a service called HTTP kernel and calls handle on it again. So that's fun, but we know how this works now. So we can go and check our service, our core.services.yaml file for HTTP kernel. Spelling it right is definitely helpful. There it is. And we know what class it loads. Stacked HTTP kernel. So all of a sudden, oops, we have left Drupal again. We're not running Drupal code anymore. So the first thing Drupal does is run a library, then it starts Drupal, and then bootstraps sort of the environment, and then leaves Drupal once more. So what is it doing here? What is this external library used for? So this is the library that it's starting up. Stack PHP. So what is this? These are very simple class. This is actually more of a method of building web applications with reusable components than any kind of meaningful library. The way this works is because of the nature of PHP applications, we have trouble with reusable components for the web layer. If I write a page cache library, generally that has to be pretty tied into my application, and it's not a reusable thing, even though I did a lot of reusable work. Using Stack PHP, or really just their methodology of using it, this lets you write these reusable layers that go around the application. They draw it as a circle here, so that goes deeper until it gets to your app, and then the response comes out the other way. Do you want to talk more about it? Okay, now there we are. But really the way this is implemented is for all these HTTP kernel classes, all they have to do is what Stack will do is it will get the first one and then a list of classes that are your HTTP kernels. And then as an HTTP kernel class, all you have to do when you start up is decide whether or not you want to call the next one in the list. Really, you don't. It just gets popped off the stack. So the next HTTP kernel that might run only knows about the next one. And it will call the handle method on the next one if it wants to. And then that one sort of still has a list, and we'll call the handle method on the next one when it's done its processing. And then it also has the option of running as the response comes back. Man, all right, Smash Mouth, bring back the old school. All right. So, what are all these HTTP kernels and how do they relate to Drupal? Well, Drupal has claimed this concept as its own. Actually, it credits it as a library, it's fine. But it exposes it to actually Drupal developers as Drupal middleware layers. And you can actually view the documentation for it here. There we are. Middleware API. So it says it implements stack PHP. So if you write a stack PHP compatible class and you keep it in your module in the right namespace, Composer will find it and load it, and we'll add it to the middle layer stack. And then you get to execute right at the beginning when Drupal does. And this documentation says this you could think of as a replacement for hook boot. I'm not sure about that, but it sounds like a good way of visualizing when this code runs right at the beginning. You have the option that to be a class that has the request and gets back the response from the next class in the chain, to actually control the way Drupal interacts, or before Drupal gets to run, you can make changes to the request, or after Drupal's run, you can make changes to the response. So the middlewares that get started up that come with core are the following, and they get run in this order. So we have a negotiation middleware. This one, all it does is it checks the accept types and the other content type headers of the HTTP request, and make sure things are kosher and that Drupal will be able to serve it. And we'll set some environment stuff and change it if it needs to, or reject the connection. The next we have is reverse proxy middleware. So if you've ever set up Drupal behind a reverse proxy, you know you have in your settings.php, you have to say like trusted reverse proxy equals this IP address, and then which are in all your reverse proxies, so that Drupal can parse out the client IP properly. That is a middleware that happens right at the beginning. When it gets the response, it then will parse out the IP address at that point. Then the reverse proxy middleware passes things off to the page cache middleware, which will then try and cache the page. It will look at the look at the request and see if it has a cached response with the right information they can use, and will serve that. And execution of Drupal might stop at this point, and we might never actually start Drupal. Well, yes, start Drupal harder than we already have. Then we have a kernel pre-handle middleware, which just sets up some more Drupal stuff, because we're actually getting Drupal started. A session middleware to load up more user information. And then Symfony component HTTP kernel. So the last thing that actually runs Drupal 8 is, again, not Drupal. It's a Symfony thing. So what is the Symfony HTTP kernel? And it seems to be oddly important because that's the last layer. This is running what Stack calls the app. And it is this Symfony HTTP kernel class. So if we look at the documentation for Symfony HTTP kernel, it says it works by creating an event dispatcher and triggering and registering event listeners and subscribers and triggering events. And then once it sets up the event dispatcher for events, it will resolve the controller and the controller. It will resolve the controller using using routers, and then it will execute the controller. Once again, a whole bunch of words, big word salad. So let's talk about some of those words. So what are events, and what is the event dispatcher? So the event dispatcher, or the events, are used in a similar way to the hook system in Drupal 7 or to events in JavaScript. Event listeners or subscribers register with the event dispatcher that they listen for certain events. Subscribers have a list of the events that they care about and register themselves. And event listeners are classes where you register when you register them with the event dispatcher, you say, when this event happens, you call this method on this class. So you can take other libraries that don't know that they're event listeners and make them event listeners. And that's really the difference between them. Subscribers know that they subscribe to events. Event listeners might not. The event dispatcher then has a list of all the events and the method or the classes or the subscribers and listeners that are registered to them, and it can then be used to trigger events. And when an event gets triggered, it knows all of the listeners and subscribers that want to know about that event and will execute them as needed. So sort of analogous to the hooks system. And of course, the events are just strings, so we can register event listeners to listen to custom events, and we can trigger the custom events in the event dispatcher. I guess I'm going late, right? Because I have till 3:30. Talk faster. So that's sort of events. The next thing that this Symfony HTTP kernel does is it will try and figure out a controller to the request. So controllers are finally the class that acts on a request and generates a response after all of this. So controllers are what generate every page, forms, entity page, and entity view. And controllers handle generating the page and processing it into markup. But before we can just start a controller, we need to know which controller matches this request, depending on what's going on. And this is done by the controller resolver. Routing classes are utility classes for the controller resolver. So frequently, controller resolvers will say, well, what is the path that the user requested? And then we have the routing controller will say, hey, I've got a list of controllers that go with the following paths. And you can just use that list to figure out which controller needs to start. And that is sort of most of the controllers in Drupal, sort of a good section of the controllers in Drupal will operate that way. And those are exposed to Drupal from Drupal itself and from other modules in the routing.yaml file. So when you're routing a module name.routing.yaml file, you are listing off what controllers, and then essentially when the controller resolver should detect that this controller should be executed for it. We won't dig into more code, and which is the most appropriate controller to execute. So, based on what we've known so far, or what we know so far, controllers, to actually render the system into markup, we know Drupal 8 uses Twig, and we know that the controllers will do the rendering of what they have, so they need to have a service that renders into Twig. So now that we know all this about the flow of Drupal, we can make an assumption that there must be a Twig service in core.services.yaml. So if we look for Twig, we have a Twig service here, and we can start making predictions about the way Drupal 8 is actually configured and actually works. So that is how you Drupal 8. Request comes in, autoloader starts, basic Drupal is bootstrapped, then the HTTP kernels run and chain down, then the controller resolver runs and figures out which controller is actually servicing the request. The controller is started and its method is called, and that generates the response. That then, then it goes backwards through the flow because the response is returned, and all of those things that just run have the option of operating on the response. And then that is how Drupal executes. We don't have a lot of time, but I actually have more slides about entities. But I think I might just skip them, and we can go to questions, because that is really the end of the Drupal dissection part. So, any questions about Drupal 8? Other than you have a brand new lexicon of words and a bit of an understanding of how Symfony applications are written. This is sort of this is the Symfony Foundation way of building applications, but more of a disassembly to figure it out instead of trying to make sense of the Symfony documentation, which is a lot harder, believe it or not. So, any questions?
How much of Drupal will be left in Drupal 9?
How much of Drupal will be left in Drupal 9? Well, there's a lot of Drupal in Drupal 8, because this is really just the bootstrap so far of what we looked at. We still haven't done anything. And so that's why I have these other slides here about sort of we missed something. Because Drupal's a content management system, and we didn't look at anything about content management. Drupal 8 stores almost everything as entities. And we didn't look at how those systems are integrated. And it happens that they're integrated via the entity manager, which is a service. So this is a service that loads and resolves all the entities we need. And there's an entity type service for the different types of entities and loading those. And so here's an example of sort of how you load a node in Drupal 8. And these services are registered with the sort of main application. And if you need entities in your controller, you say, through dependency injection, you can just say, my controller needs entities, so give me the entity service, and then you'll get that and be able to load entities. Then there's essentially two kinds of entities that we have to store, configuration entities, which store site configuration. And we have sort of the base class for them here. And they don't have database schemas. They're just sort of stored into the one database table for config and have an ID. They have their own stack of code that lets them integrate with the configuration management interface. They don't have bundles, but they're sort of their own thing for storing data. And we also have content entities, which are stored in this content, which come from this content entity base class. And that's for storing stuff actually into the database. They have fields like we recognize. They have schemas, so they don't work with CMI, and they can have different kinds of types. And fields work very differently in content entities in Drupal 8 than they do in Drupal 7. In Drupal 7, every field has a different field storage controller class that controls how they actually get put into the database, or not put into the database, excuse me, put anywhere. Just almost 100% of the time your fields are stored in the database, you just use the field SQL storage container. But in Drupal 8, all of the content entities essentially implement or inherit from the SQL content entity storage class. And fields are actually managed by that class. And so their SQL schemas are actually loaded, and then when you load an entity in Drupal 8, it actually loads the field data as well. And it needs to do this in Drupal 8 because everything is a field. There aren't the idea of properties other than the IDs and stuff. So the whole idea of fields and content entities are now sort of one, even though we call them two different things. And the fields are sort of, which field an entity has, content entity has, is configurable, but it is sort of one thing that gets loaded out of the database.
So how much more work is it to create the same Drupal 8 project if you had to compare with Drupal 7?
The same Drupal 8 project?
You had to learn, you had to adapt, you had to move up. I mean, what's the inflation?
The inflation, they really work as they're two different platforms altogether. I think last year, this is Drupal North here, Adam Bernstein did a presentation on migrating your module from 7 to 8, and he said, you gotta just rewrite it and do a whole analysis of it, and that is very true. And it's true because for the sort of deep fundamental level, the Drupal 8 at a code level, like it's amazing how much they made the UI look the same and kept the UI and content management topics, but everything else is different, and the way things work are different. And if you have a module, you need to, and you want to port a date, you have to ask some really existential questions about that module. Like, does Drupal 8 need this module, or does Drupal 8 actually just do this in core now? Or does it do it in a different way that sort of negates the whole purpose and horizontal date of this module? And or does it have new tools that make it so this module is actually implemented in a completely different way? And it really is, you're really going to end up in one of those buckets. Probably in that you have new tools so that you're going to do it in a different way. If you were just writing an API module, then sort of you're in luck because you take your module class or your module file, turn it into a service and stick object, class name, whatever around it, register it in a YAML file, and you might be done. But even then, there's a whole set of different tools that come from Symfony. And if it's an API module, all of a sudden we have Composer, and we can load other PHP project as dependencies. So we don't need to even have API modules anymore. We can have PHP code and then just load them with Symfony, load them with Composer as external dependencies. So, yeah, I hope that answers your question.
So 25-30% at least more.
Yeah.
I'm guessing.
Well, it depends on what you were doing before. That's sort of the thing. Because there's some stuff that can port over, and there's some stuff that is sort of, there isn't a parallel, because it is a very different framework.
And if you learn PHP from Drupal like I did, that's Drupal 8 is completely different. You have to rewrite. You know, you have to figure out everything from scratch, pretty much.
So Drupal's old code base is based really on PHP 4, before objects existed. And when PHP was a very simple language, modern PHP is not the PHP of yesterday. It is a full-featured language, and all of the old quotes about PHP sort of denigrating it haven't made sense in a really long time. And Drupal 8 takes advantage, because it uses Symfony, which is sort of a modern PHP framework, takes advantage of all of them. From the very first line of index.php, it takes advantage of the auto-loading functions. That, like, at a core level, it's now using all of the new stuff. And with the new array syntax that only started existing in 5.6, and that is in the PHP standard of like the way that you write Drupal 8 code. So, like, there's a lot of new stuff, which is kind of sucks for old PHP developers who were used to a certain way, and now you have to learn that. What's the difference between implements and extends? And you can implement from multiple classes, but you only extend from one. What is going on here? So you have to. There is a lot. There's sort of a computer science learning curve that you actually have to do to really get started in it. Sorry, you had a question.
Yeah, that makes sense from that. So if you have Drupal 7 custom code and you're using the BSR 4 standard and you're using the XML node and stuff like that,
yeah,
is that a good starting point to move into Drupal 8?
Yeah, because I mean, if you're doing sort of modern PHP stuff and using Composer, right away, like as you saw when we looked at sort of the Drupal directory structure, you already see like what's going on, and can sort of deduce things about Drupal. I think I'm really over time. Is the other one started? Is somebody supposed to be talking now? Hopefully you're not in the room.
15 minutes left.
It's a 15-minute break? All right, cool. Then I'll keep answering questions. I thought I was like going over somebody's presentation. Oh, geez, I'm sorry. So is that enough of an answer to your question?
Yeah.
All right, cool. Any other questions? No? I got more bracelets. They're also USB keys. Here, all right. Well, then I'll stop this.